In this lesson, we'll discuss something we haven't touched on yet, linking files. Instead of making copies of files all over your system, it's sometimes desirable just to have links to one file. This is done with soft links or symlinks, or with hard links. A link is similar in concept to a shortcut in Windows. Links are pointers to the actual file. There are two types: soft links, often referred to as symbolic links or symlinks, and hard links. We'll discuss both in this lesson. Before discussing that, though, we'll take a look at inode numbers. You'll understand why shortly. Along with a name, every file is assigned an index or inode number. The inode number is how the system actually tracks the file. If we type ls minus li, I is to show the inode number, we'll see a leading number before the rest of the information on the file. That number is the inode number or index number. Every file on the system has its own unique inode number. The number of inodes on a system is limited, but it's very large depending on the file system in use. If we type df minus I, we can see the status of our inode usage on the system. We can see here the only file that's using an appreciable number of inodes is this dev mapper ubuntu server vgroot, which is part of the logical volume manager or LVM for this system. But it still has plenty of space. It's used only 24% of the available inodes. Most directories have only used less than 1%. You could get more information about a particular mount point with the tune2fs command. If we want to have a closer look at the dev sda1 mount, we would type sudo tune2fs -l /dev/sda1, and then we would grep for inode, because that'll give us a lot of additional information. So it tells us file system features, inode count, how many are free, inodes per group, blocks per group, first inode, and inode size. Now let's see how inodes relate to links. We have two files here, locs or locs.txt and locs2.txt. To create a hard link, we would type ln file name link name. Now if we do ls minus li again, we can see that locs and the hard link have the same inode number. It's essentially two names pointing to the same underlying file. Creating a soft link is very similar, but we add the -s option, so it would be ln -s file name and link name. Now if we do ls minus li, we can see there's a new soft link here. You can see it's light blue. That means it's working. It's not broken. And you can see an arrow pointing to the file it's linked to, the file name it's linked to. And you can see it has a completely new inode number. So a soft link essentially links to the name of the file, not the inode number. So how do these behave? Changing the name of a file with a hard link will not break the link, as it's pointing to the inode number, not the file name. We move locks to locks2. We can see both files are there. Both are still referring to the same inode number. And if we cat locks new, if we cat locks new.txt, it works. If we cat hard link to locks2, that also works. However, the same is not the case for soft links. If we cat the file now, it works. If we change the file name, we can see the link now shows as red, meaning it's broken, because locks2 is no longer there. If we try and cat that file, it doesn't work. The link is broken. Similarly, if you delete a file that has a hard link, the hard link still works. And the contents are still there. If you delete a file that has a soft link, it also won't work. How are these used in practical terms? If you have a web server, chances are the files that tell the server what pages are active will be symlinks to another file. Also, system files often use symlinks. That way you can change just an original file and all the links pointing to it are also seeing the new information. I don't have a web server on here, but you can see that rc0.d also uses links. All of these are links to files in initd. So that's it for links, hard links and soft links. On to the next lesson.